Chapter 9, Thermochemistry, Exercise 9.75, Part A. Calculate the enthalpy of reaction for this. Aluminum oxide reacting with 3CO, carbon monoxide, to produce 2 aluminum and 3 carbon dioxide. We're given this information, 2 other chemical reactions. They're all balanced. This is aluminum reacting with oxygen to produce aluminum oxide. The second reaction here is carbon monoxide reacting with oxygen to produce CO2. We have the enthalpy of reaction here and here. Pay attention to the unit. Supposedly it should be kilojoule per mole, but Trill book is not really quite rigorous about this. So this number actually means we have enthalpy decrease with this negative sign, enthalpy decrease of 1675.7 kilojoule per mole such reaction. And per mole such reaction means 1 mole of this is produced, 2 moles of aluminum is consumed. Same here, this number means the enthalpy decreases by 282.7 kilojoule per mole CO2 produced or per CO consumed. Alright, let's look at the question. How can we compute the enthalpy of reaction for this? There's a trick here. All you need to do is to identify some chemicals that appear only once in here and only once in here or here. Let me give you an example. I see aluminum oxide Al2O3 here, and I see that here, but it does not appear in this reaction. Then we know that we have to flip this reaction, so to get aluminum oxide to appear on the left hand side. And when you flip this chemical reaction, the sign of delta H must change. So let me show you the calculator here. What we need to do is this. We'll have to flip the sign. So I'm going to put a plus sign here just to emphasize the change of the sign. So we need this to place aluminum oxide on the left hand side of this reaction. And now let's look at CO. I think CO appears only in here. Alright, and we need to have 3 CO on the left hand side. So that means we need to multiply this by 3. Alright, so negative 282.7 multiplied by 3 to ensure that 3 COs are on the left hand side. And we get this number 828. So 828, it's a positive number. So 828, it's a positive number. That means the enthalpy of the reaction system increases. All right, submit. Let's take a look here. You can see over here we need 3 CO, so we multiply this chemical reaction by 3. Alright, and at the same time we multiply this delta H by 3. Alright, also we need to flip this reaction to have aluminum oxide on the left hand side. That's why this becomes positive.